Hi children, a warm welcome to another chemistry class. In today's class, we are going to discuss some important questions from the chapter S block elements of the 11th standard topic. S block elements. Once again, warm welcome to the classes. Let's start. The first question. We need to identify an incorrect statement concerned to beryllium. First one, it salts rarely hydrolyze. That itself is the incorrect statement. You have learned beryllium compounds are highly covalent when compared. So beryllium compounds being highly covalent, that will easily hydrolyze. So that itself is the incorrect statement and hence the answer. What about the other options? Its hydride is electron deficient and polymeric. That is the true statement. They form electron deficient compounds and their hydrides are polymeric in nature. Textual statement and fact. It is rendered passive by nitric acid. Yes, like aluminium, it is rendered passive by nitric acid due to the formation of a thin oxide layer. And fourth one, it forms beryllium carbide. Yes, it forms beryllium carbide and the carbides are methanides in nature like aluminium carbide. Aluminium carbide, beryllium carbide, that's a typical example for the diagonal relationship. They give methane gas upon hydrolysis. So the correct answer is option 1. Okay. Next question. Option 1. Suspension of slaked lime in water is known as. Suspension of slaked lime in water. You know, lime, that is calcium oxide undergoing slaking process, you get slaked lime, that is calcium hydroxide. A clear solution is called a lime water, while a turbid solution is called a milk of lime. Padichittonda. And the correct answer is option 1, milk of lime. While a clear solution will be called a lime water and a turbid solution, that is a suspension will be called milk of lime. Milk of lime. Next one. Ionic mobility of which of the alkali metal ion is lowest in aqueous solution? Right? See, that concept is related to hydration. And the answer is which one? Ionic mobility is greatly depending on the size of the ion. So when you think in that context, lithium being the smallest ion having high ionic mobility, that's a possible answer. But the answer is, high mobility is lithium. That's a possible answer. But the actual point is that lithium being smaller in size, it undergo heavy hydration. And due to the hydration, the size of hydrated ion will increase and its mobility will decrease. So even though the ionic size of lithium is minimum, the ionic mobility of lithium, the ionic size of lithium is minimum and the expected ionic mobility to be maximum. The ionic mobility, the electrical conductivity of lithium is minimum in the aqueous state. Why? Because of severe hydration. Due to small size, it undergo heavy hydration and thereby the size increases and its ionic mobility decreases. Its electrical conductivity decreases in aqueous solution. And the answer here is, no doubt, it is lithium. So why lithium? Once again, listen carefully. Lithium is small, making small ion. Li plus is the smallest ion among alkali metals. As all of you know, down the group size increases. But being a small ion, it undergo heavy hydration. So due to heavy hydration, when water molecules are enveloped, the size of the aqueous ion will increase. When the size increases as a result of hydration, the ionic mobility decreases. And electrical conductance offered will be minimum hence. So here asked is lowest ionic mobility. Lowest ionic mobility is lithium. And cesium is larger ion and is expected to give minimum mobility, but it is giving maximum mobility because it is not hydrated at all because of larger size. Okay, next. Most acidic. Barium oxide is basic, magnesium oxide is weakly basic, calcium oxide is bit more basic, while beryllium oxide is answer as it is amphoteric in nature. It is amphoteric in nature. Amphoteric means both acidic and basic character. The rest all are basic in nature. And down the group, basic strength increases. While beryllium oxide, it is amphoteric in nature. I am sure all of you know beryllium is not included in the definition of alkaline earth metal. Beryllium does not fall under the definition of alkaline earth metal because it is not alkaline. It is amphoteric in nature. So when you ask for comparative acidic strength, it is being amphoteric, it is having highest acidic character when compared because the rest all are relatively more basic. Okay, next question. The order of ionic character of hydride. Order of ionic character of hydride depends on the electropositive nature of the metal. So down the group, electropositive nature increases. Therefore, ionic character increases. So what is the answer? Option 3, beryllium, calcium, barium. Down the group, the metallic character, the electropositive character increases. Therefore, ionic character increases. Next. Magnesium react with X to form ionic compound. If the ground state electronic configuration of X is given, see, it's very simple to understand X is nitrogen. It's very simple to understand X is nitrogen. So what will be the ionic compound formed between magnesium and nitrogen? No doubt, magnesium divalent 2 plus, nitrogen trivalent 3 minus. No doubt about it, it's magnesium nitride. Mg2, Mg3N2, Mg3X2, third choice. Mg3X2, third choice. So here easy to understand, X is nothing but nitrogen. Nitrogen is forming nitride, magnesium forming Mg2 plus, hence the formula. Next question. Third choice is the correct answer. Next one. Amphoteric hydroxide. Amphoteric hydroxide. Why there is a doubt? No doubt required. Beryllium hydroxide. Beryllium oxide is amphoteric in nature. Okay. Next. Enzymes that utilize ATP in phosphate transfer require an alkaline earth metal M as cofactor. See, this is you can find in NCERT in the biological importance of alkali. Of course, alkali metal, sodium, potassium referred, alkaline earth metal, magnesium, calcium, etc. referred. In the last portion of each group referring in the S block, biological importance. Many important points are referred there and which can come as an objective question like this. And all of you know it is magnesium. Enzyme that use the same sentence you can find in the textbook. The enzyme that utilize the ATP in phosphate transfer require an alkaline earth metal which is nothing but magnesium. And similar many other points are referred in that long one paragraph. Each line can come as an objective question. Right? Hope you might have remembering the quantity, the relative quantity of sodium, potassium, etc. Right. Next. Following metal ion activates many enzymes participate in oxidation of glucose to produce ATP, and with the sodium is an ATP and with Na is responsible for another question from the area which I have told, and it is potassium. Third one, potassium. Potassium ions are the most abundant cations within the cell fluid, where they activate many enzymes, participate in the, see, each line is important. Most abundant, where? Within the cell fluid, within the cell fluid. There are similar traps there in the textual sentences. So you have to read the NCERT line by line, word by word, probably in between the lines also. Next one. HCl passed through solution of calcium chloride, magnesium chloride, NaCl. Which of the following compounds crystallizes? Which one will be crystallizing? You see, HCl passed through CaCl2, MgCl2, NaCl. See, this question has got a commercial industrial importance also. In the preparation of soap industry, a process called salting out of soap. Salting out of soap done by using this particular process also, and it is NaCl. NaCl, when HCl passed through mixture of Cl ion concentration increases, hence the ionic product becomes more than solubility product, and NaCl will be precipitating out. What is the concept involved that you are learning in the chapter equilibrium? Common ion effect. Common ion effect. Right? And this particular context we are utilizing in the purification, refining of common salt. A saturated solution of common salt dissolved in water after several stages of purification, the crystallization is done by adding or passing HCl. When you pass HCl, you can see that NaCl easily precipitate out as a result of increase in concentration of Cl minus, and as a result of common ion effect, NaCl precipitate out. While calcium, magnesium are more soluble, their solubility is greater, right? Therefore, NaCl will precipitate out. So this question has got commercial importance, industrial importance. Okay, next one. Largest value of KSP, high KSP. Which one will have high KSP? KSP means solubility product constant. Solubility product constant high means solubility is high. So which is having high solubility? Among alkaline earth metal sulphate, you know the solubility decreases down the group. Beryllium sulphate, highly soluble, and that is the answer. Magnesium sulphate, okay, it dissolves, but as you come down, solubility vanishes. Barium sulphate is insoluble. Barium sulphate precipitate as white precipitate, insoluble. Right? So the answer is largest KSP means largest solubility. Which is having largest solubility? Beryllium sulphate. So it is having largest solubility product constant. Next question. Option B. A white solid Y on heating gives off a gas which turns lime water milky. The residue is yellow when hot, white when cold. The solid is zinc carbonate. See, this easily will give you the answer. The residue is white, yellow when hot, white when cold. With the change in temperature, zinc oxide will undergo a change in color from white to yellow. It's so-called a philosopher's wool, famous known as. It is due to crystal defects. It is due to crystal defects. Zinc carbonate, when you heat, you will get zinc oxide and carbon dioxide. And this is actually giving, the gas which turns lime water milky. And we are talking about this. This is yellow when heated and white when cooled. And it is due to crystal defect. Zinc oxide, that's why it's known as philosopher's wool. Zinc oxide. And that information enough to understand which is the correct choice. Option C. The pair of compounds which cannot exist together in aqueous solution is. A pair of compounds which cannot exist together in aqueous solution is. First choice itself, because this is an acidic salt. All of you know the reaction of H3PO4. You see that H3PO4 can interact with NaOH and you will be getting NaH2PO4 plus H2O. Now, it can further react with NaOH and you will get Na2HPO4 plus water, second term neutralization. It can further react with NaOH and you will get Na3PO4, the last salt, plus water. So the reaction will proceed up to that. So whenever you are taking a combination of this along with this, there will be reaction and they cannot exist together. They will react and you will get a product. And that itself is the answer. While the second one, sodium carbonate, NaHCO3. This is the final salt, no reaction. Sodium, Na2HPO4, Na3PO4. That is a final salt, no reaction. This is a final salt, no reaction. So the answer is option A. A frequently coming question. Next. A compound which can be used in submarines for absorbing carbon dioxide and liberating oxygen is Na2O2, the one which is very famous called oxone. Oxone. It is called oxone, the which can absorb carbon dioxide and release oxygen. It can be used in submarines. It can be used in heavily crowded area, like heavily crowded hospitals, tunnel railway stations. Heavy crowding when comes and there is a emergency situation of decreasing oxygen. It can be used. Okay, next. And this is the reaction. Na2O2 with the carbon dioxide. It forms sodium carbonate liberating oxygen. It is sodium peroxide, famous known as oxone. NaNO3 on moderate heating gives. NaNO3 on moderate heating, you will be getting this. Upon moderate heating, you will be getting NaNO2 liberating oxygen. NaNO2 liberating oxygen. Option A. Option A. Suppose it is lithium nitrate. Suppose it is lithium nitrate. Hope you remember the anomalous behavior. LiNO3. LiNO3. You will be getting Li2O, NO2 plus oxygen. Lithium nitrate is behaving like some heavy metal nitrate. While all other alkali metal nitrate, you will get metal nitrite liberating oxygen. Okay. That is the anomalous behavior of lithium versus other behavior of other alkali metals. Okay. Next. A characteristic property of alkaline earth metal is that the ratio of IE1 by IE2 is much higher compared to that of alkali metals. Yes, first choice itself is the correct answer. First choice itself is the correct answer. You know, IE1 for alkali metals is low. You see, we are talking about what? We are talking about IE1 by IE2 for group 1 alkali metals and IE1 by IE2 for group 2 alkaline earth metals. You see the statement, the ratio of IE1 by IE2 much higher compared to that of alkali metals. So when you compare for group 2 and group 1, group 2 value will be very high. And it's very simple to understand. You see that IE1 value for group 1 will be low because it carry only one electron in the outermost shell, while IE2 value is relatively high because you are trying to remove electron from the core. So IE1 low value, IE2 high value. So the ratio is low value. The ratio is low value. That's it. While when you compare this IE1, IE2 value of group 2 versus IE1, IE2 value of group 1, this is a low value, this is a high value. And this is a high value when compared because only one valence electron. So IE2 value for alkali metals will be high. Therefore, IE1, IE2 value will be low. I think it is clear. Next question. Yeah, we have a comparison there. Even. You see that sodium, IE1 for sodium, magnesium, the nearby members. Sodium 496, second value 4500. So the value coming around 1 by 10. While magnesium 737 and 1500 range, the value comes out to be half. You compare just one comparison. If you take similar comparisons, you can understand for group 2, IE1 by IE2 is larger value. Okay, next. Dead burned plaster. You know, gypsum. This is gypsum. Gypsum on controlled heating. You will get plaster of Paris, and gypsum on heavy heating, you get dead burned plaster. It is anhydrous calcium sulphate. Gypsum on controlled heating, you will get plaster of Paris, calcium sulphate, hemihydrate. While the same gypsum, heavy severe heating, it will lose all the water of crystallization and the setting property, everything gone, and it is called dead burned plaster. Anhydrous calcium sulphate is called dead burned plaster. Anhydrous calcium sulphate is called dead burned plaster. Next one. And this is plaster of Paris. And heating up to 400 Kelvin, you get that. Heating up to 473 Kelvin, you get the entire water molecules are removed. Next question. Magnesium carbide on hydrolysis gives. Beryllium carbide gives methane. Aluminium carbide gives methane. While magnesium carbide gives propine. Magnesium carbide gives propine. These are some important points you must know. Beryllium carbide, you will get methane. Aluminium carbide, you get methane. Calcium carbide, you get ethane. While magnesium carbide, you get propine. So magnesium carbide on hydrolysis, the product obtained will be option C, propine. And this is what the reaction. Next. Most covalent. See, when you compare lithium, beryllium, no doubt, beryllium is more covalent because the size is small. When you compare lithium, beryllium, beryllium is more covalent. So choice AD and BC. Choice AD and BC. So we will cancel B and C. Now between A and D, which is the answer? No doubt A. According to Fajan's rule, larger the anion, higher the polarization, higher the covalent character. See, Fajan's rule you can apply. Covalent character depends on the polarization, and polarization increases with the size of the anion. Okay, so cation must be small in size, anion must be larger in size. A small cation, large anion, you get high polarization, high covalent character. Okay, next question. Washing soda crystals, when exposed to air, crumble to a white powder by loss of water. Loss of water. Absorbing of water is called deliquescent. Losing of water is called efflorescence. A hydrated crystal losing water molecule. A hydrated crystal evolving water molecule. It depends on the aqueous tension of the air also. So according to the character of the atmosphere, if you have a hydrated crystal which loses water, it is called efflorescence. While a anhydrous crystal absorbing moisture from air, that is called deliquescent. Deliquescent. This is what called efflorescence. Hydrates losing water of crystallization and becoming partially dehydrated or completely dehydrated. That is called efflorescence. Okay. Next. CO2 cannot be used for extinguishing fire produced by burning magnesium metal. You might have learned when magnesium metal burning, you can't use carbon dioxide as a fire extinguisher because magnesium can interact with the CO2. Magnesium can interact with the CO2. Option B. Magnesium can interact with the CO2, and using the oxygen of carbon dioxide, magnesium will be converted to magnesium oxide. Using the oxygen of carbon dioxide, magnesium will be converted to magnesium oxide. Burning magnesium continue to burn in carbon dioxide, forming MgO. It will abstract oxygen from CO2 and it will be converted to MgO. I don't have to tell you, MgO is highly exothermic stable compound. Okay, next. Increasing order of solubility in water. Increasing order of solubility in water. Least soluble, calcium carbonate. So we are cancelling this because that will precipitate. And the next solubility, sodium bicarbonate. Answer is option D. Calcium carbonate, insoluble. It will precipitate. Now, when you compare sodium bicarbonate and potassium bicarbonate, potassium bicarbonate is more soluble. As you come down, solubility of bicarbonates increases. Right? So the answer is option D. Probably this is the reason why you are not being able to produce potassium carbonate in Solvay process. Solvay process, we are producing washing soda, sodium carbonate. How it is produced? Ammonia reacting with the carbon dioxide, you get ammonium carbonate, then you get ammonium bicarbonate. Treating with NaCl, you are getting sodium bicarbonate precipitate out. And that upon heating, you get sodium carbonate. So sodium bicarbonate, upon precipitation, you are heating, converted to sodium carbonate. Such a precipitation is not possible commercially with the potassium bicarbonate because it is more soluble. So in Solvay process, we are unable to produce Like washing soda, we are unable to produce potassium carbonate because of the relatively more solubility of KHCO3. You are learning in NCERT. Next question. The correct increasing order of solubility. Already commented, the solubility decreases down the group. Solubility decreases down the group. Beryllium, magnesium are soluble, while coming down barium is insoluble. So which is having high solubility? Increasing order of solubility. Increasing order of solubility. This is out, this is out. Beryllium, magnesium, calcium, strontium, barium. Option B is the correct answer. Beryllium maximum and comes gradually. Beryllium, magnesium, calcium, strontium, barium, like that. Option B is the correct answer. Next. MNO3 twice, giving MOX plus O2, where M is beryllium, magnesium, calcium. See, alkaline earth metal nitrates. Alkaline earth metal nitrates behaves like lithium nitrate. They will give you metal oxide, NO2, brown colored NO2 gas, and oxygen. So what X is? You are getting metal oxide. What X is? Nothing but NO2 gas. Brown colored NO2 gas is evolved plus oxygen. Okay. So this is the reaction. You are getting metal oxide, NO2 and oxygen. So X is nothing but NO2. Next question. Increasing order of basic strength. Increasing order of basic strength. Basic strength increases down the group, whether group 1 or group 2. The basic strength increases down the group. So what is the answer? Minimum beryllium. Minimum beryllium. These two are out. Beryllium, calcium, Allah. It is beryllium, magnesium, calcium, strontium, barium. Option A itself is the correct answer. Okay. Down the group, basic strength of hydroxides, oxides increases. The correct decreasing order of hydration enthalpy. Hydration enthalpy depends on extent of hydration. Extent of hydration depends on the size. Smaller the size, heavier the hydration enthalpy. Right? So what is the order? What is the order? Beryllium, high hydration enthalpy due to small size. So this is out, this is out. Then beryllium, magnesium, calcium, strontium, barium. Regular trend. Answer is option B. Smaller the size, heavier the hydration enthalpy. Right? Next. Beryllium chloride with lithium aluminum hydride, you are getting X lithium chloride AlCl3, a reaction which you find in the textbook. A reaction which you find in the textbook for the preparation of beryllium hydride. You see, beryllium does not react combine directly with hydrogen. A sentence from the NCERT itself. You can't prepare beryllium hydride directly. It can be prepared by such a method. Beryllium chloride with lithium aluminum hydride, you are getting BeH2. Answer is option not C. Answer is option B, beryllium hydride. Next. Increasing order of mobility of alkali metal ions. Mobility, already discussed. Mobility depends on size. Then there is a possibility that we commit an answer, lithium small size, high mobility. Actual answer is opposite. Why? Aqueous solution. In aqueous solution, lithium because of small size undergo heavy hydration. So what happens? The size increases, mobility decreases, electrical conductivity decreases. So lithium will be minimum. Lithium will be minimum. And the order is increasing order of mobility. Lithium, sodium, potassium, rubidium, cesium. Option A. Lithium, small size, heavy hydration. So after hydration, size increases, mobility decreases. Cesium, large size. It does not undergo hydration. So the mobility is high. Answer is option A. Next. E0 value of some electrodes are given below. Decreasing order of reducing strength. See, reducing strength can be decided by taking the E0 value. You see, E0 A bar B, you will check for high negative value. You will check for high negative value, right? And this species will be strong reducing agent. If you want to check the reducing agent with reference to standard reduction potential, you do one thing, select for the high negative value, number 1. And your answer will be the one species on the right hand side of that bar. Okay? Keep that in your mind. So how do you select? Reducing agent, high negative. This is high negative, so maximum lithium. Maximum lithium. So this is out. Next high negative. This one, next one is sodium. Next one is sodium. Lithium, sodium. Next. High negative means low value. High negative means low value. So this gone, which is other low value. 0.79. Now rest all are positive. Take the low value. 0.79, 0.53. This is the next value. Take I minus. So lithium, sodium, Ag out. Lithium, sodium, Cl minus out. Option A is correct. Lithium, sodium, I minus. The next value will be silver, 0.79, Ag, next value. And this is the last one, Cl minus. Option A is the correct answer. I'm sure you might have seen this question in the NCERT. It's a solved question from the NCERT. And such questions are coming for the actual entrance examination even this year. Right? Next. The half-life of francium is, another factual point from the textbook. You might have seen 21 minutes or so. Yes, exactly. Option A, 21 minutes. It is short-lived, very short-lived francium is. Right? And that falls our last question from the chapter. We have tried to include some important coverage from the chapter, including all possible area which are competitively important. Right? So we will meet. We are winding up that chapter discussion here. That is S block elements. Right? We will meet in another class with another chapter, another few more important questions from the next chapter, next class. Okay, bye, see you, take care.